We always like to start with sine. So our sine squared angle identity is equal to 1 minus cosine of 2 times my angle u divided by 2. The cosine squared angle identity is equal to 1 plus cosine of 2u over 2. And the tangent squared identity is equal to 1 minus cosine of 2u over 1 plus cosine of 2u. And we're going to do 2 examples.
Why did you like the cosine 2u if you're just going to make that something different there?
If I'm just going to make the what?
Cosine 2u. Oh, there's 3 of them.
Yeah. You guys ready? No, you guys don't look excited at all.
Yes.
It's a Thursday. Why is it?
Bro, you guys tell me it's only a Friday right now? I can't see. Who is that?
Homer said it's waiting for me to have later.
We just keep pushing it off, not do.
Yeah, it's gonna be all due tomorrow.
What is it tomorrow?
I pushed so far. Oh, well, thanks.
Okay, so for this example, we are going to verify the identity sine squared x cosine squared x equals 1/8 times the quantity 1 minus cosine of 4x. I think it looks like fun.
It's like when seniors like, yeah, this one's really easy. And then the entire class goes,
It's just Spanish.
Like how you understand Florida.
Okay, so in order to verify this identity, we are going to work solely with the left-hand side of the equal sign, and then we're going to keep simplifying it until we get it to match what's happening on the right-hand side of the equal sign. That's how I know I'm finished, just like the previous identity proofs. So as I'm looking at sine squared x, cosine squared x on the left-hand side, who has an idea of how we're going to start this? Do our squared identities that we just wrote down. So I can replace sine squared x with 1 minus cosine 2u over 2, but we're going to use x instead of u. And I can replace cosine squared x with 1 plus cosine 2x over 2. Right? I just used my squared identities to replace those. Now I'm going to do the super, super fun thing that is multiplying those two things together and foiling the numerators.
Oh my gosh.
So when I do that, it becomes 1 times 1 is 1. 1 times positive cosine 2x is positive cosine 2x. Negative cosine 2x times 1 is negative cosine 2x. And then negative cosine 2x times positive cosine 2x becomes negative cosine squared 2x. And that's all over 4. Right? Do we see what I did here? I'm going to give you a second to catch up.
why doesn't this class work like those two class together? Why does it turn into a point?
Because I'm not multiplying what's inside together. I was only multiplying the outside trig function together.
Okay.
Yes, ma'am.
Are we trying to make the sides equal to each other?
I'm trying to make this left side turn into that. Do we notice anything happening right here? Cody? So what's going to happen to those? Cancel out. Perfect. I I'm also going to go ahead and pull that denominator 4 out and write it as 1/4 in front of all of the numerator because I hate the fraction. So this is the same as 1/4 times 1 minus cosine squared 2x, right? Because those cosine 2x's canceled out just like Cody said they would, and I pulled the denominator 4 out front and just rewrote it as 1/4 times that whole quantity. Anybody have an idea what we're gonna do next?
Yeah, I can't talk.
What's 1 minus cosine squared equal to?
Science.
Sine squared by our Pythagorean identity. Yes.
Why does it matter?
Say it louder, honey.
Why would we do that?
But it's gonna be easier to work with because if I leave it like this, I'm putting a fraction inside of a parentheses that already has a whole number in it. So I actually would make it more complicated if I didn't try to change it into one term versus keeping it as 2. So that's the whole point of doing the replacement is I changed what's inside to one term, which is a lot easier to work with in the end than 2 terms that just keep adding on to each other. So- I do, but that's okay. That just means when I take sine squared, it's gonna be sine squared of 2x. We always just make the angle match. So what we notice is I have the Pythagorean identity, but it wasn't written like that. I had 1 minus, so I subtract the cosine squared over, and I get that sine squared of 2x is equal to 1 minus cosine squared of 2x. 2 times an angle is just another angle, so we can have 3x or 4x or 1/2 x inside of that Pythagorean identity, and it doesn't change the identity itself. Okay, I always just change the angle to match whatever's happening in my problem. So once I recognize that 1 minus cosine squared 2x is equal to sine squared 2x, I'm going to replace that whole parentheses with it. Then I just have one term that I'm working with on the inside. So this becomes 1/4 times sine squared of 2x. This does not match what I currently have going on the right-hand side of my equal sign. But I'm one step closer to getting it there because I know sine squared of 2x is equal to what? We just wrote down our squared identities, didn't we?
1 minus cosine squared over 2.
So this is 1/4 times 1 minus cosine of 2 times my angle 2x over 2. So by changing that down to one term, I was able to use the identity that we wrote down already. And now I have a cosine back in here that doesn't have a square on it, so I'm one step closer to making it match what I currently have on the right-hand side of my equal sign. I can definitely simplify this a little bit more. First off, I can pull this 2 outside and multiply it into the 4 that's already a denominator. So my outside becomes 1/8. And then 2 times 2x becomes 4x. And now I match what I was intending to match on the right-hand side of the equal sign.
Confusing the
My angle was 2x, and then the identity said I did cosine of 2 times whatever my angle was.
Oh, okay.
Yeah, I just took that directly from here, and it's 2 times u, and my u here just happened to be 2x. So now I show that they are equal to each other so that I can close my proof. How do we feel about that one? Bad, terrible, awful.
Yes.
This is also very new to you, so it's okay if you struggle to try to figure out what we were doing next. That's why we're doing these, okay? And we do have one more example, and then we are finished. You guys ready?
We're gonna do it anyways.
We are gonna do it anyways.
So are you planning?
So this example would ask, or sorry, not would ask, would like us to take the expression cosine to the fourth power of t and turn it into a function that only has cosines to an exponent of 1. So I want nothing but cosine functions, and I want no exponents larger than a 1.
What is that basic?
Don't just be cosine. There would be no exponent on there, yes. But no exponent is the same. You guys ready? Oh. Who has an idea of where we're going to start?
Split the two cosines and squareds instead of fours.
Okay, so cosine to the fourth is the same as cosine squared squared. So this becomes cosine squared of t squared.
But if you square it, G also have an exponent?
No, because I'm technically only squaring the cosine function. The t just happens to be inside the cosine function. Are we all okay with how we did that? If it helps, you can remember that cosine squared of t is the same as cosine of t in parentheses, all squared. So again, we're not squaring the angle here, we're squaring the function itself because it's a composite, so it doesn't work the same way we think it works. I have that, so now what am I gonna do? What cosine thing?
I have that.
Which I did.
So with cosine squared, that means 1 plus cosine.
Yeah, I'm gonna use my squared identities that we just wrote down. I have a cosine squared identity, so that's the one I'm gonna use. So when I do that, this becomes 1 plus cosine of 2t over 2, all squared. Right, because cosine squared is equal to 1 plus cosine of 2 angle over 2. We wrote that down at the very top. And now, just like on the previous problem, I'm going to go ahead and rewrite this as the multiplication times itself. And then I'm going to FOIL by multiplying straight across. So this is equal to 1 plus cosine 2t over 2 times 1 plus cosine 2t over 2.
That because of the square.
Yes, it's because of the square. So when we square something like this, we don't just square what's inside of it. We literally multiply it by itself. When I do that, the denominators make 1/4, which I'm going to go ahead and put out front just to make it a lot easier. And then this becomes 1 plus 2 cosine 2t plus cosine squared 2t. We are almost done.
You just have to get the exponents out.
I just have to get the exponents out, yep.
The twos and everything, okay.
All the 2's are okay as long as they're not as an exponent. So do I have everything down to an exponent of 1? No. What term is not?
Cosine squared.
That last one. But it's cosine squared, so I have an identity that I can use to change that into something that just has a singular cosine function in it, right? What's cosine squared equal to? 1 plus cosine 2t over 2. So I'm going to go ahead and do that. This then stays 1/4 times 1 plus cosine 2t plus parentheses 1 plus cosine 2 of 2t over 2. Well, we definitely don't want to leave it like this. This is really ugly.
Fraction.
But we can multiply the 1/4 into all of those, right?
You just need the fraction out front.
Well, I can put it, but it's only going to apply to these two terms. It's not going to apply to these. So that's why we're going to multiply the 1/4 in, and then we'll simplify that last parentheses. So when I multiply the 1/4 in, this becomes 1/4 plus 2/4 cosine 2t plus 1/4 times 1/2 plus 1/2 cosine 4t. Right, so I split this up into two terms, and then I'll distribute the 1/4 in there as well.
Why don't you distribute it out? Or
Distribute what out?
like,
The 1/2?
no. 1 plus cosine 2t. Why don't you make that part of the parentheses?
Because I didn't like it. You do it your way, I'll do it my way. So this becomes 1/4 plus 1/2 cosine 2t plus 1/8 plus 1/8 cosine 4t. And then we just need to put like terms together. Do I have any like terms that I can combine? The 1/4 and the 1/8. How do I put those together? It's like, I have to change 1/4 to a denominator 8, so I need to multiply it by 2/2. So this becomes 2/8, and then I add the 1 to it, and I get 3/8 plus 1/2 cosine 2t plus 1/8 cosine 4t. And then I'm finished. Does that kind of make sense? So honestly, sometimes the hardest part for these is just the simplifying. And if you're doing it on your own and you like this far and you stopped, that would be worth most of the credit. Okay, most. I would maybe take off like a point for not finishing the simplification process. But I looked more for the process that you can substitute the identities in than the process that you can simplify. I'd rather you focus on the identities before this. Okay, and then that's it. So today, the rest of the class is for homework. And then if you have questions, of course, let me know. Tomorrow's going to be a practice day. Figured you guys could use it after this week.